Hey, what's up? My name is Sullivan. I am a graduating senior at Plymouth State University. I'm going to talk about some different forms of climbing today. And obviously it's April, but I still want to focus on ice climbing. So I'm going to provide a bunch of pictures in the video to kind of give you a better understanding of what it is that I'm talking about, but I can show you a lot of the gear right here out of the back of my car. So in ice climbing, unlike rock climbing, where you have a climbing shoe with a really sticky rubber sole and you're relying on friction on the rock, ice is a really low friction surface, and we can't just climb that with specialized shoes. We do have a couple different tools to get up the ice. So the first step to ice climbing are your mountaineering boots, your crampons, and your ice tools. This is a mountaineering boot. So we use this for both snow travel and walking, and also vertical ice climbing. The difference between this and a regular boot is that no matter how hard I try, this sole isn't going to flex. It's a full shank mountaineering boot. You may ask, why doesn't this bend? Your hiking boots bend, your walking shoes bend. It makes walking really easy. But the difference is we're going to be putting all of our body weight into a small steel point coming out the front of our boot. So we need all of the support of the mountaineering boot and all of that weight to be transferred from the boot to the crampon. So if you wonder what a crampon is, I'm going to pull that out next. This is a steel ice climbing crampon. This one's obviously a little bit more rigid. It's meant for dry tooling, so climbing on rock and also ice. This one has 14 steel points, but oftentimes it's 12 steel points. And it has a vertically oriented front point. Vertical oriented front point, this one right here, instead of being like a shovel, which is a horizontal front point, it's like a knife blade. The reason that this is important is since we're climbing ice, we don't want to displace a lot of that. The ice is what's keeping us into the wall, so if we're removing a lot of that, we're not going to stay on the wall for very long. So this vertically oriented front point is removing the least amount of ice as possible. So you may wonder how this attaches to your boot and why this is important. So I rigged one of the boots up to demonstrate. You can see that based on the crampon, which we just looked at in the mountaineering boot, we have a toe welt, a hard plastic front, kind of like a ski boot, and a heel welt, also kind of like a ski boot. This is sort of along the lines of a binding, where it attaches into that front toe welt with a toe bail, this steel silver piece, and with a heel lever, very similar to a ski binding. So the stiffness of the mountaineering boot combined with a tight crampon, this provides a really stable ice climbing platform. I'm going to attach a couple pictures to sort of see what that looks like on the ice. So we kind of covered our feet. Now we got to talk about our arms. So contrary to popular belief, even though what I'm going to show next looks like the more technical, the more advanced tool, ultimately the thing that's getting you up the climb is your feet. However, we do need to stay attached to the wall, and if we don't have a way of doing that, we're going to fall off backwards. So I brought two modern ice tools. They currently have the same downturned steel picks for vertical ice climbing. I'm going to attach a picture of a mountaineering axe that we use in snow climbing, just so you can see the difference in shape. First one I'm going to talk about is an alpine ice tool. So if you can see this whole thing, it has a relatively aggressive shape. So it's still meant for swinging into vertical ice. However, the difference is the grip attached to the shaft of the ice tool is in line. So this makes it really easy to use on low angle terrain. And it also makes it really easy to use in snow. I can plunge it kind of like a cane. So this is oftentimes what you're going to be using as a beginner, and also if you're doing really big expeditions where you're transitioning between snow, ice, and rock often, we're going to use one of these ice tools. Another modern ice tool that I pulled out is what we call an ergonomic ice tool. So this is a Petzl Nomic. It's a vertical waterfall ice tool, and this is meant for steeper ice. So you can see the difference from the grip up. It's kind of the same shape. The shaft is the same shape. The pick is the same. The head, everything is the same. Where the difference comes into play is this ergonomic grip. So what this grip does for me is it changes my wrist positioning. So if I were to have an inline grip and I were climbing steep ice, the angle of my wrist would be really acute. It would be bent a lot, and I'd get tired really quickly. I'd bash my knuckles when I was swinging, and ultimately I'd get tired and fall. With an ergonomic ice tool on steep ice, it pushes this handle back so that the angle of my wrist is neutral. When I'm ice climbing, I'm using 2 of these tools at any given time. And I'll provide pictures of that. So we sort of covered the basics of climbing. Kicking in with my feet, swinging in with my arms. And sort of like rock climbing, I need to find a way of protecting myself on the ice. So in ice climbing, there's not going to really be any ice cracks. There's no protection that I can place. There's nothing that I can clip that stays there forever. So what I'm going to be placing is something called an ice screw. A couple different examples of ice screws of different length, but they're all relatively similar. You have a long steel or aluminum shaft that's partially threaded and sharp teeth at the end with a hollow center. Modern ice screws also have a crank arm, and almost all ice screws have a hanger like this. If you've ever been indoor rock climbing, or even to Rumney, you're probably pretty familiar with these hangers. I'll get into that in a little bit. So when you're ice climbing, as I'm hanging from a stance, so I have one ice tool in the wall, I have 2 feet, what I'm doing is I'm screwing this ice screw into the ice. As I push in on the ice screw, these teeth are engaging the ice, and it's actually shredding it or destroying it in front of the teeth and sending it through the middle of the tube. You may ask why this works. So unlike rock protection, where sometimes you're relying on leverage, you're relying on other pieces of metal, these threads are what's actually holding the ice screw into the ice. So as you pull down on it, the threads are engaging with the ice and preventing it from pulling out. They come in different lengths, not necessarily because the longer ones are stronger, but you can use the different lengths to engage better ice farther in to the frozen waterfall. After I've placed an ice screw, I'm going to take a sling or a quick draw with 2 carabiners, clip it into this metal hanger, and then take the rope that's clipped from my harness, or that's attached to my harness, it's going down to my belayer. I'm going to bring it up, clip it into place, and keep climbing. Sort of continuing the trend of protection in ice climbing. Ice climbing is a wintertime sport. There's snow, there's water, there's ice. It's really wet. problem is with climbing, most climbing soft goods, so slings, ropes, anything that's made out of a material, as we climb up and as those things get wet during the day, they lose strength. So in order to mitigate this, when we're ice climbing, we have a bunch of different high-tech materials that are non-absorbent. They don't take in any water. So I brought 3 different examples today. Each have different applications. So this right here is a pretty traditional ice climbing extendable quick draw. The center material is a super lightweight material called Dyneema. It's stronger than steel, super static, there's no stretch, and it doesn't absorb any water. It's very lightweight. This is also another example of Dyneema. The difference is on this one is the little blue stitching on the outside is actually made out of nylon. And lastly, we have a cordelette, a long 5.9 millimeter cordelette. Outer core is made out of nylon, the same thing climbing ropes are made out of. And the inner, the outer sheath I should say, the inner core is made out of something that bulletproof vests are made out of, Kevlar. So Kevlar is super strong for its weight, and it's also doesn't absorb water. So it's not going to lose strength as we climb. Just like our climbing soft goods, like our slings and our quick draws, the rope also can't absorb water. So this is a little bit about ice.